What this is doing when we create a hydrogen bond, which is the bond of water, okay? It's actually the bond between the chromosomes, your DNA. But here's the thing. It's weak, but it's strong. What do I mean by that? Water, I keep saying, exists in all three states. It is the only substance that does that. As a liquid, whatever we drink, okay, bonds are doing this number, breaking, forming, breaking, forming, breaking, forming, breaking, forming. All right? When water freezes, and we think of ice, okay, what do you think has happened to the bonds? Where they were breaking, forming, guess what? They're now in a, they're going to be in a pattern. What happens when we boil water? And it becomes steam. Bonds have done what? They've broken. Okay? We have broken those bonds, and we've now created the steam. However, what temperature does water boil? 212 Fahrenheit, 100 Celsius. All life is dependent on water. All life. So let me think here for a second. Do I ever get to 212 degrees? Hey, I paid $10 to see that. But, just saying, you know. Now, I think that's kind of beneficial. All right? What about freezing? 32 Fahrenheit? 0 Celsius. Now, think about this for a second. Okay? We just had a couple of days where the temperature got down to what? 1 degree? All right? But what can happen to you if you have exposed areas and temperatures like that for an extended amount of time? They're going to freeze off. So, we can freeze, right? But still, how long, or do we really have that type of situation always available? You know, usually you're going to be protected in some way. The clothing, the shelter, whatever the case might be, okay? So this huge fluctuation in this temperature, okay? And then, based on the bonds that are found between the water molecules, is the reason life exists on this planet. I mean, what is it that they're searching Mars for so much? Water. And they think they found it. All right? Hey, I don't know. I ain't going to be around to see or find out or be able to book my trip or anything. So, you know, I'm like, okay, so this is the reason, okay, that water, one of the reasons, that water is the reason that we have life on this planet. Now, granted, there's lots of other properties about water that are important, okay? Trust me on that. But the bonding at this point for us, it's a hydrogen bond. The hydrogen bond, basically, we're going to also find between the two strands, those chromosomes, our DNA, okay? But because of the attraction that it has, it makes for a very strong bonding that occurs to hold the two strands of DNA together. So we have our ionic bonds, which are going to be extremely important to us. The polar covalent, where they're sharing it equally, sharing it with unequally, non-polar, equally, and our hydrogen bonds. So those are the bonds that are going to exist. Now, if we get back to the ionic bonds, one of the reasons that this becomes important, we pretty much, depending on weight, are mostly water, anywhere from 70 to 95%, okay, water. Now, we take in substances, i.e. our foods, okay, body has to break them down into their component parts so that we can take those little tiny parts and send them on their way to do their job. These ions that are so important, they're going to have the ability for electricity, okay, to generate what is going to be termed a membrane potential, okay? Now, they do that because they break apart in a water environment. You take that salt particle, put it in a water environment, water, because guess what? Water has a negative part, positive part. When those ions break apart, they're breaking apart into a negative and a positive. Well, if my sodium is positive, guess which part is going to be attracted in a water molecule? The negative part. So the negative portion, that oxygen, will surround sodiums. My chlorine is negative. Guess which part of the water molecule is attracted? The positive. They form around those negative particles. And now we have those particles available in the body. Now that we have them available, okay, basically they have dissociated. They have broken apart, okay, because they were able to dissolve in the water. And now what we have created is an electrolyte. Heard of those? Why? Have you heard of them? Okay. Gatorade, the first one invented. Have lots of others now, like Powerade and stuff like that, and they tout them to us in what way? How do they want to sell that product to us? For use for what? Well, the electrolytes, they're selling it to us to replenish what we've used in the body after vigorous exercise. Drinking them all the time, not good. Okay, because your body is not in any way going to use that much. Okay, so it's not healthy to just drink them all the time. And really, unless you have actually done something that has really made you sweat and exercise for a good amount of time, you probably shouldn't drink them.
It might be like off topic, but how come when you do, like, I guess, do figures, like activities and stuff, I don't know, I've heard that a lot of times they say like Gatorade water. Is that because they don't want to put too much electrolytes in at one time, so that's why they want you to switch it?
Mm-hmm. Because, the body, I mean, even though you might take in the Gatorade, it's going to be a huge amount of the salts, okay? And chances are, unless you're like a Olympic athlete, you don't need those two Gatorades right after each other. Or maybe a pro football player or pro basketball player. Yeah, chances are you haven't done that much to burn that much off. Yeah. So these are our electrolytes, and those electrolytes are going to become Very important. Now, one of the things that I mentioned, membrane potential. So guess where I have now taken you to? To what level have I gotten you to? My cellular level, and what part? Our plasma membrane, the cell membrane. What did I say yesterday? Everything was going to be dependent upon. The cellular membrane. So I have now taken you down to the level that everything is going to happen at this point. Okay? All right, we'll start at this point notes tomorrow.